All right, here's the mineral review. Okay, so learning from last time, maybe a little bit more. There are about 300 known minerals, and rocks are made of one or more of those minerals. The mineral chart in your reference table is located on the back or page 16. There are 21 minerals listed, which you will be responsible for 10. All right. If you were in class, we would be working with these 10. So the 10 are the top two, the galena and graphite. I would highlight, underline. And then you're going to go down and you're going to skip a couple and you're going to go down to talc, sulfur, and selenite gypsum. Skip the muscovite and go for the next three, halite, biotite, and calcite. And then you're going to skip down 4, or at least down to the 5th one, to potassium feldspar. That one you're going to want to know. And then olivine. All right, so the identification test. We did talk about this last time. Color. Color is usually a poor test in minerals because a lot of them have more than one color. How do you know? If you look just at talc over here in the colors, it says white to green. It doesn't have just one color. It's got a couple colors. So in this, there are some that have, in the 10 that I've given you, 2 of them have color, like actual color. You have this one, which is yellow and sulfur, and then this one is green, or olivine. Green is olivine. And then you have luster. So minerals are generally classified into 2 lusters. They're either metallic, which means shiny like a piece of metal, or non-metallic, which means they're not. All right, so I just showed you a couple right here. Sulfur, and then you have olivine, and then you have potassium feldspar. You have galena. You have selenite gypsum. You have halite. You have calcite. You have talc. You have graphite. And then last but not least, when I can get it out of here, you have biotite mica. All right, out of those, only 2 are metallic. Well, you don't have the minerals at home. How do you know? Looking over here at the very, very side, it tells you which ones are metallic and which ones are not. Well, which 2 of the 10 that I've given you are metallic? You've got graphite and galena. Those 2 are metallic. And you'll see that when I show you right there. Very shiny like metal. Non-metallic is everything else. Now you say, hey, Miss Co, there was one that looked like it was metallic-y. But it really isn't metallic. It is just a black shiny. You see, look, it's just a black shiny. It's not metallic at all. All right, then you have streak, which is uses a streak porcelain plate, and you run the mineral across it to see if the mineral leaves a colored streak. These are listed in the distinguishing characteristics column. So a streak, there are 3 of them, by the way, that make a streak. So what you do is you take your mineral and you run it across. And you can see I just made that nice little streak mark right there. And then if I take this, I'm showing you the 3. Go like that. There's another one. And last but not least, this one's a hard one to see. You can kind of see it right there that I just did. So the 3 that I just did is sulfur. That yellow one is sulfur. Then I did graphite and galena, which kind of makes sense with the graphite because graphite is in your pencil. So yeah, it would leave a streak because it leaves a streak on your paper. That's how we can see your pencil marks. Colorless streak, that's everything else. That's all 7. They do not leave any streaks. You would think that maybe they could, but they don't. Then number 4, you've got the cleavage and fracture, which again, you can find in your reference table. It is just this line that has a check on either side. And another note, something you could kind of like underline or highlight is in the distinguishing characteristics. It'll tell you if it's a cleavage, what type of cleavage it is. So, what is fracture? Fracture means if I was to take a hammer and I was just go smack and hit the mineral, it would break into 1,000 pieces, like random pieces. Cleavage, on the other hand, means if I was to take that same hammer and go whap, it would break into nice, even pieces. And like I said, in the distinguishing characteristics, it will tell you what type of piece that it breaks into. So looking at this, which ones have cleavage, which ones have fracture. So most of the ones that I gave you all have cleavage. There's only 2 that fracture. And if you look, sulfur and olivine are the 2 that do that. So the colored ones actually fracture. They break off into little itsy bitsy pieces. Everything else cleaves in some way or some form. So the other 8. And like I said on this, you can see like graphite is definitely a cleavage. Galena says it's cubic. That means it breaks into small chunks. You'll also notice that galena is the only one that gives you its density. Then if you look down to calcite, it says rhombohedral. Halite says cubic. We're going to skip those. Potassium feldspar in 2 directions at 90 degrees. So you can kind of see how it has this 90-degree angle almost with this one for the potassium feldspar, and olivine fractures. All right, so hardness. This is a scale of 1 to 10, with 1 being really soft and 10 being really hard. So examples of hardness. 1. I actually have 2, but you really should write down this one. This is talc, and the other one is graphite. But the reason why I don't say graphite is because graphite can be anywhere between 1 and 2. And 10, which I do have right there, is a diamond. So ways to do this test. Your fingernail, like I showed you on Friday, is a 2.5. If it scratches the mineral, then the mineral is less than a 2.5. So the best one I have is the selenite gypsum, and I kind of showed you when I scratch it with my nail, it kind of has like a little snow shower. A copper penny, that is a 3.5, so it's a little bit harder. And then a glass plate right here,
10 billion.
that will be a 5.5. So if I can scratch it, and I do apologize, I can scratch it. There's like little scratch marks from this. You can't really see it too well, but this one actually does scratch. All right, so looking at your reference table right along the side, it does tell you the hardness. It's under the hardness section. So graphite, just looking at graphite, it's got the 1 to 2. Now here's the thing with the graphite. 1 to 2, if you are in art, or if you've taken art, you'll notice that some art teachers, like Miss Merrithew, have pencils, graphite pencils, that are labeled 1, 1.5, 2, or 2 just like you use in class. That's because they have the different hardnesses. The harder it is, the more it's apt to stay on your page and not be as erasable. So you'd want to sketch with the softer ones and really put in that one that you want to keep, that drawing you want to keep in that 2. All right, and then you have galena. That's a 2.5. Talc, again, that's a flat 1. Sulfur's a 2. Selenite gypsum's also a 2. Halite is a 2.5. Bitype mica is a 2.5 to 3. Calcite's a 3. Potassium feldspar is a 6. And olivine is a 6.5. Again, you can find that right here. All right, so now we have this flow chart. This thing we kind of looked at on Friday. So how you're going to want to go through this is really simple. You're going to take either looking at the mineral or your reference table. Either one can walk you through this. So the first things first, graphite. Is it metallic or non-metallic? Well, if I'm looking at it, I know it's metallic. But I can also tell where it is along, this line. Metallic or non-metallic? Well, I know it's metallic. Does it cleave? Well, let's see. It's on the cleavage side. If you can't really tell in class. I will not be giving hammers. You know it cleaves. Does it leave a color streak or a colorless or white streak? Well, and then I could test with my streak plate, or I can look right here in the distinguishing characteristics, which it says a black streak. So there is a color streak. Is it hard or soft? Remember, like 5 is your midpoint. So if it's above 5, it's hard. If it's below 5, it's soft. So this is definitely soft because it's 1 to 2. My mineral letter is going to be A. Now let's say we go through galena, which is right underneath it. We know it's metallic, and it definitely cleaves. It leaves a gray-black streak. It's a 2.5, is soft. It is also an A. Here's the thing with the flow chart. Each letter does not have a specific mineral attached to it, which means several minerals can have the same letter identifying it on this flow chart. So if I was to take through talc, I would get a K. So talc is non-metallic, it cleaves, it is colorless, it is soft, it gives me a K. Sulfur, all right, so sulfur is non-metallic, it fractures, it leaves a color, it is soft, it gives me an M. Selenite gypsum, non-metallic, cleaves, colorless, soft, gives me a K. Halite, non-metallic, cleaves, colorless, soft, K. Bitype mica, non-metallic, cleaves, colorless, soft, K. Calcite, non-metallic, cleaves, colorless, soft, K. Potassium feldspar, non-metallic, cleaves, colorless, white, hard, L. Olivine, last but not least, non-metallic, fracture, colorless, white, hard, P. All right, so that's it for right now. If you have any questions, don't hesitate to ask me. Use this for all your notes for your quiz. Besides that, I hope you have a great day.